What if the glitches in our universe hint at a hidden, parallel realm? At CERN, 3 separate research teams have documented the same quantum anomaly, showing information traveling between seemingly unconnected states. Evidence suggesting our universe isn't alone. Welcome to the cutting edge of physics, where the Large Hadron Collider's latest experiments have yielded bizarre data that scientists are considering what was once unthinkable. Today, we'll examine the perplexing evidence that the scientific community is both excited and deeply concerned as they grapple with what could rewrite our understanding of existence. What if the Large Hadron Collider isn't just smashing particles, but accidentally punching tiny holes in the fabric of our reality? Deep beneath the Franco-Swiss border, CERN's massive scientific instrument accelerates particles to nearly the speed of light before orchestrating spectacular collisions. These aren't ordinary crashes. They're recreations of conditions that existed just moments after the Big Bang, when our universe was still in its infancy. The primary purpose of the LHC has always been clear: to help us understand the fundamental building blocks of our reality. Scientists expected to find new particles and confirm theories about how our universe works. The anomalies have startled the physics community, strange patterns in the data that have left some of physics' brightest minds searching for explanations beyond our current understanding. During high-energy collision events, the LHC's detectors have recorded energy spikes and particle behaviors that don't align with the standard physics model. These stunning bursts of energy defy known rules, hinting at an unseen realm our current formulas fail to capture. The deviations suggest something profound occurring during these experiments. The anomalies manifest as what scientists informally call glitches in the data. Imagine tracking a particle's journey through the detector, only to have it seemingly vanish for a microsecond before reappearing further along its path. It's like discovering secret passages in a mansion you thought you knew every corner of. These aren't just measurement errors, they're consistent enough to suggest something real is happening beyond our current understanding of physics. Among the most intriguing experiments at CERN is the Totem project, which stands apart from other detection systems by its focus on measuring proton-proton interactions. While the Atlas and CMS detectors search for new particles, Totem has recorded data hinting at unknown interactions beyond our reality, detecting patterns that some physicists believe could be evidence of particles briefly interacting with another dimension. When certain particles appear to vanish momentarily during these high-energy collisions, they are not necessarily disappearing into nothingness. Some theoretical physicists have proposed that these particles might temporarily exist in another dimension, essentially taking a shortcut through a different plane of existence before returning to our observable universe. It's as if these particles are playing an interdimensional game of peekaboo, briefly slipping through cracks in the fabric of our reality. This concept aligns with advanced theoretical physics. Models like string theory have long predicted the existence of extra dimensions folded into our space-time that could interact with our reality under the extreme conditions created by the LHC. These additional dimensions typically curled up tightly, but they might unfold when enough energy concentrates in a small space, precisely what happens during these collisions. What makes these anomalies particularly fascinating is that they don't appear random. The glitches occur with subtle patterns suggesting order rather than chaos, as if following rules of physics we haven't yet discovered. Some patterns even hint at what could be described as intelligence or design, though most physicists caution against such dramatic conclusions without further evidence. Perhaps most provocative is the notion that the LHC could create conditions conducive to forming miniature black holes. According to some theories, these could point to entire universes hidden in higher dimensions. While incredibly small and short-lived, these holes might be just large enough to allow particles to slip through briefly, explaining the mysterious vanishing acts observed in the data. When particles flicker in and out of our reality, traditional computing hits a wall of impossibility. These miniature reality punctures have created a cosmic puzzle that conventional computers simply cannot solve. But what if the key to decoding messages from other dimensions requires a machine that, like those dimensions themselves, exists in multiple states at once? Enter quantum computing, the only technology that speaks the same paradoxical language as the universe itself. Imagine trying to decipher a language where the letters change with every glance. This is precisely the challenge CERN scientists face when interpreting signals that hint at dimensional crossovers. While our everyday computers process information through binary code, rigid ones and zeros, quantum computers utilize qubits that mirror the very phenomena they're trying to detect, existing in multiple states simultaneously until observed. This revolutionary approach to computing calculates differently, not just faster. When a traditional supercomputer attempts to model particles that appear to cross dimensional boundaries, it must laboriously check each possibility in sequence. Picture trying to solve a million-piece jigsaw puzzle by trying one piece at a time. Conventional machines simply choke on calculations involving quantum phenomena that might indicate parallel dimensions. Quantum computers embrace the strange logic of quantum mechanics. Through superposition, they process countless possibilities simultaneously, considering all a million puzzle pieces at once. They establish connections between separate qubits, regardless of distance through entanglement, creating computational relationships that mirror the quantum phenomena in CERN's particle collisions. While the LHC reveals nature's cryptic signals, quantum computing has become our translator in this cosmic dialogue. CERN has integrated cutting-edge quantum systems into its research framework. Google's Sycamore processor and D-Wave's quantum systems are essential translators for the quantum language of interdimensional signals, woven into the Large Hadron Collider's data analysis infrastructure to process information in previously impossible ways. The unique power of these quantum systems lies in their ability to simulate multiple possible realities simultaneously. When particles appear to vanish during high-energy collisions, they might briefly exist in superposition across different dimensional states. Quantum computers, operating on identical principles, can model these bizarre behaviors by exploring all potential reality configurations in parallel, revealing patterns completely invisible to classical computing methods. Picture scientists on a quiet night, eyes wide as their quantum computers illuminate patterns that challenge everything known about reality. CERN researchers have begun identifying dimensional echoes, subtle patterns in collision data, suggesting particles aren't simply disappearing, but interacting across different reality states. These distinctive quantum signatures emerge clearly when analyzed through quantum computational models. As quantum computing power increases, CERN researchers develop increasingly complex models showing our universe might be one of many sheets in a multidimensional reality. Imagine our universe as a single page in an infinite cosmic book, with particles occasionally slipping between pages during moments of extreme energy concentration. Quantum computers effectively read across multiple pages simultaneously, detecting faint impressions left when particles press through from one reality to another. The quantum computer's native ability to process multiple reality states creates a unique detection advantage, recognizing patterns suggesting boundary crossings because they operate by similar quantum principles. They become sensitive instruments detecting quantum fingerprints left behind when particles interact across dimensional boundaries, tuning into the quantum static between dimensions and extracting meaningful patterns. Conventional computing simply cannot perceive. Reality glitches, the Mandela effect, and CERN's dimensional experiments. Beyond the quantum computers listening for dimensional whispers, our own consciousness might be the most sensitive detector of reality fluctuations. Have you ever been sure of a memory shared by thousands of others only to discover it never happened? These collective false memories, scientifically documented as the Mandela effect, might be more than mere psychological curiosities. They could be the human mind's way of registering dimensional shifts occurring during CERN's most potent experiments. The term Mandela effect refers to those strange shared misconceptions experienced by large groups of people. Consider the thousands who vividly remember Nelson Mandela dying in prison during the 1980s, complete with emotional memories of funeral coverage, when in our timeline, he survived to become South Africa's president and died in 2013. Or how masses of people recall the children's books being spelled Berenstain Bears, when they've always been the Berenstain Bears. Could our collective memory be echoing an unseen quantum event? These consistent specific alterations to cultural touchstones that large populations share with remarkable similarity suggest something profound. This phenomenon extends beyond internet folklore. It has scientific validation. Psychologists Wilma Bainbridge and Deepasri Prasad from the University of Chicago empirically confirmed what millions suspected through groundbreaking research. Their experiments revealed participants consistently misremembered specific details in identical ways, even when claiming high familiarity with the images. Our minds may be like radio tuners, catching signals from another frequency, occasionally picking up whispers from a parallel timeline. When participants were shown images of popular characters like Pikachu, they misremembered key details and remarkably consistent patterns, despite claiming intimate knowledge of these cultural icons. This structured shared phenomenon defied conventional memory psychology. When thousands of strangers independently make the same mistake, something more profound might happen. What's particularly intriguing is how these mass memory anomalies cluster around specific time frames. Analysis reveals a correlation between major Mandela effect reports and periods when CERN's Large Hadron Collider conducted its highest energy experiments. The surge in reported effects following the 2016 restart of the LHC at 13 TeV, that's nearly double its previous energy level, presents a pattern that beckons deeper investigation. This timing raises a provocative question. Could CERN's extreme experiments momentarily destabilize the boundaries between neighboring realities? Imagine our universe as one page in an infinite cosmic book. The extraordinary energies generated by the LHC might cause the pages to flutter against each other, creating brief moments where memories from parallel timelines bleed through into our consciousness. The scientific foundation for this possibility lies in quantum physics' fundamental principle that particles exist in multiple states simultaneously. When CERN pushes particles to extreme energies, they may briefly occupy quantum states that transcend dimensional boundaries. If human consciousness operates on quantum principles, as some theoretical physicists propose, our minds might register these quantum fluctuations as memory discrepancies. Similarly, when CERN conducted specialized experiments probing quantum boundaries in 2018, online communities documented new waves of reality discrepancies affecting cultural memories. While correlation doesn't prove causation, the timing and nature of documented Mandela effects and their empirical validation by respected research institutions suggest a connection extending beyond psychological explanation. The patterns align too precisely with periods of high-energy quantum experimentation to be dismissed entirely. Standing at the precipice of discovery, CERN's next frontier brings profound questions about our place in the cosmic tapestry. What happens when our scientific endeavors tear at the very fabric of dimensional boundaries? Imagine unzipping reality itself, uncertain of what awaits beyond. Some physicists voice concerns about dimensional interactions. Could we inadvertently destabilize our universe through scientific curiosity? If we develop the ability to peer across dimensional barriers, what moral framework guides our actions when consequences might ripple across the multiverse? With each advancement, the line between speculative fiction and tomorrow's headline blurs. As CERN teeters on the edge of cosmic discovery, we must ask, are we merely observers or active participants in a multidimensional tapestry? Our understanding of reality itself transforms as we venture into uncharted cosmological territory. If you're as fascinated by space as we are, you won't want to miss these other videos. We dive even deeper into the universe's secrets and explore recent discoveries that could revolutionize your understanding of the cosmos. Thank you for joining us on this cosmic adventure. Stay curious and keep looking up.